Hello there. Today we have the problem called decode message. Given the map A equals 1, B equals 2, Z equals 26, and an encoded message as a string, count the number of ways that can be decoded. So for example, if the message is 111, there are 3 ways it can be decoded. It can be decoded as 3 A's, an A and a K, or a K and then an A. So this straight up looks like a dynamic programming problem. From the onset. What I see here is my first observation is ways, number of ways. That means equals dp or a subset. But we're not looking at a subset. We're looking at number of ways, combinations, and we're looking at the ways it can be. So 111. It can go down this particular path where it starts with a 1, and it could also start with a path called 11. So we're adding these two paths together, and this path particularly goes down 2 paths where it's 1 again, or 11, and then this path goes down to the a single item. As you can see here, this particular path tells us these 2 paths here is the same, and we could reuse that. Right? You see that 11, 1 and 11, 1 here. So we start at 1, we have the number of ways we can get 1, and then we go to 11, we get the number of ways we can get 11. It's K or an A, and or an AA. So we know the number of ways, which is I think two ways, and then we add a third way to it. And so yeah, that is how we'll build up this particular problem using a dynamic programming approach and getting the number of ways we can start at a single item and start adding it on to more and more pieces of the item. Okay, so let's start with a dp equals. So the thing about these dp problems, I think it's all about just practice, getting more practice in and learning about how to write these dp problems and the way it kind of looks. So I'm not too familiar with these processes yet. I'm still working on it myself. So just more practice would be good. So first thing is we're looking at zeros. If the item is a 0, let's say it starts with a 0 here, then we can't do anything with it because 0 doesn't map to anything. So let's gonna set that dp of I equals 0. So there's nothing that is here at this particular point to add on to add on to our results. Otherwise, dp of I is going to equal to dp of I plus 1. That means that we'll take everything that is from the previous item, basically this particular case here, where there's 1 way, and then there's one more thing we're going to add. There's one more thing we can do, which is check if it's between 1, if it is 1, and then and there's a previous item, then we're going to add those possibilities to our current dp, because that way we know that we have all of those ways too. So it's either a 1, either we're starting with a 1, that means a 0 through 9 is possible. Otherwise we have to do a 2, and message of I is I plus 1. That means the one before that, I mean next item, is in 0 through 6. With that, we can set dp of I plus equals dp of I plus 2. So what we did here was that we took the previous item and we're going to add the 2 previous items because this diverged and created a brand new path and had that X amount of options, a tree behind that. So with that, we can return dp of 0 and we should be good to go. Let's run it. Oh, we have an issue. Equal and run it. Looks like we're good to go. And we have a solution. So DP problem, let's see what we learned today. What we learned today was number of ways when they were asking that, usually a DP problem, and how to and get more observations about like what is valid, what is invalid, how to build it up, what sort of possibilities are possible, and how to get more out of a problem. So we got a lot out of this problem by looking at the ways the strings can be built up and what are possible and what's not possible and what's good and what's bad. Zeros are no good. And if we see anything, we just pull the previous item, and if we see a split, if it was split in the then we add all those possibilities too. If there's a split, add I plus 2, which is 2 before that. Yeah, because if you have a like 13 and then everything before that is this much, and everything before that is this much, see? And that's how we get everything. Yeah, great problem. I think I would like to do more DP problems in the future. Of course, it's best to do them and learn. So thank you very much. I hope you learned something today. If you enjoyed the video, like and subscribe. And if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.